So going along with our logic discussion, we're going to now look at some proofs. And proofs are just a nice way of showing your logic when solving a problem. So the learning target we're going to keep in mind is I can use the properties of real numbers to prove the answer to an algebraic problem. And before we can really look at solving proofs or doing proofs, we have to talk about properties of equality. So these are properties that you've been using all throughout your math life, you just didn't know it. So when I look at the addition property of equality, that says that if A equals B, then A plus C equals B plus C. So adding the same number to both sides keeps my equality. Subtraction property of equality is going to be the same thing. It's going to tell me that if I subtract the same number from both sides, I'm going to keep that equality. Multiplication property of equality, again, I can multiply both sides by the same number and keep my equation balanced. Division property of equality works the same way. I can divide each side by the same number and keep my equality. Now this distributive property you guys have been using a lot, and you used it a lot last year in algebra. So that's just saying that if I have a number on the outside of parentheses, I can distribute that number to both things and it becomes AB plus AC. If I look at the substitution property, it's telling me that if A equals B, then A can be replaced with B in an expression or equation. And that one will make a little bit more sense when we start actually doing our proofs. We also have the reflexive property, and this one is going to be used a lot in proofs, and it says for any real number, A equals A, so a value equals itself. We also have the symmetric property, which says that if A equals B, then B equals A. We're just sort of flipping the order, but again, it's keeping that same equality. And then the transitive property is going to be used. So we have if A equals B and B equals C, then A equals C. So this is sort of like our law of syllogism. It's just with properties and with solving equations. So now we can actually take a look at solving some proofs. So when we do our proofs, we're going to do a two-column proof. We do that so we can sort of organize it in a more consistent way. So the left side of my proofs are going to be my statements or my steps. It's how we're actually solving. The right side is going to be the reasons that justify each step. So what property is working that lets me do that. To do our reasoning, we're going to use properties like the ones we just talked about, different definitions and postulates and theorems that we learn all throughout the course. And those will get more in depth when we start looking at some of our geometric proofs. But right now we're going to stick with our properties for our algebraic proofs. So when they give us a proof, they're always going to give us a statement, and they're going to give us a given, and they're going to tell us what they want us to prove. So in this case, I have 4x minus 1 equals 27, and I want to prove that x equals 7. The first line of our two-column proof is always going to be what they gave us. So it's my 4x minus 1 equals 27. And our reason is always going to be given. It's sort of just a givey, like they just give you what you want to put right there. Then we're going to work on solving all the way down to our prove statement. So when we're solving this equation, just like we normally would, our natural thing to get x by itself is going to be to add 1 to both sides, which is how they got 4x minus 28. For my reasoning with this one, I want to figure out what I did to get from step 1 to step 2. Well, in this case, I added 1 to both sides, so I used the addition property of equality. And I'm not going to have you write out of equality. You can if you want to, but we can just write addition property. Now I want to figure out how to get down to my prove statement. So if I want x to equal 7, well, I need to divide both sides by 4. To get from step 2 to step 3, with that division, I use my division property. And that's just how we're going to do our two-column proofs. So we're going to do a couple more examples. My next given is a divided by -6 plus 2 equals 5, and I want to prove that a equals -18. So again, my given statement is always going to be my first line, and that's always the reason of it was just given. Now, between step 1 and step 2, they subtracted 2 from both sides to try and get a by itself. If I'm subtracting 2 from both sides between step 1 and step 2, I used the subtraction property. To figure out what I did from step 2 to step 3, they got rid of my -6 on the bottom, and they did that by multiplying both sides. So we're using our multiplication property. Now you know that you're done when your proof statement is the very last line of your proof. So the first line is your given, and your very last line should be your proof statement. Number 3, we have a given of -9 times the quantity 2x minus 3 equals 63, and I want to prove that x equals -2. So again, we have our given statement and our given reason. Then between step 1 and step 2, we have to figure out that they used the distributive property. Next thing we're going to do is figure out what they did between step 2 and step 3. And it looks like they got rid of our 27, and they did that using our subtraction property. The next one is they got x by itself to equal -2, and they did that using the division property. So you're solving all the equations you did in algebra. We're just writing it out in a different way. And now we're justifying with the properties that we're using. We're going to go over number 4 and 5 a little bit quicker, but there is something important with number 4 that I do want to show you. So again, our given statement is the very first line, and then we're going to figure out what they did between step 1 and step 2. And in this case, they did the subtraction property. They subtracted that 6x. Between step 2 and step 3, they used the addition property, adding 17 to both sides. Between step 3 and step 4, they used the division property. Now, right here between step 4 and step 5 is what I want to talk about. They went from 12 equals x to x equals 12. And this is an example of that symmetric property that I was talking about. All they did is flipped the order. So it didn't change it in any way. They just flipped from 12 equals x to x equals 12. So that's an example of our symmetric property. Again, number 5, we're going to go through pretty quickly. They did the distributive property first, and then they simplified, and that is allowed to be a reason. That's just your combining like terms. Then they subtracted, and then they added, and lastly they divided. So those are our proofs. Now in this case, all of our statements were written out for us. They solved it, but that's not always going to be the case. In fact, most of the time you're going to have to do the whole thing on your own. So we're going to go through a couple of examples where they don't give us anything and we have to write it all out. So my first example is they gave me that 3x plus 1 equals -14, and that's always my first line of my statement. Now you do want to number them so you can keep track. So number 1 is 3x plus 1 equals -14. And when we number, we also need to number the reason. So the reason we have this is that it's given. To get our next line, we just want to start solving so we can get down to our proof statement. We're going to subtract 1 from both sides to get 3x equals -15. Since I subtracted 1, we're using our subtraction property. I still want to get down to my proof statement of x equals -5. So I now need to divide both sides by 3 to get the x equals -5. And that is my division property. Now, we do have an extra line, but we didn't need it because we know we're done since we got our prove statement. Number 2 is going to work the same way. So I'm going to take my given statement and write that as my first statement. Number 1 is 2 times the quantity x minus 9 equals negative 10. And my reason for step 1 is that it was given. And then I'm just going to go through and solve normally. So I would use the distributive property, and that's my reason. To solve next, we're going to add 18 to both sides. So we're using that addition property. And then we're going to use our division property to get x equals 4. I always want to make sure that my last statement is my proof statement, so I know that I'm done. I'm going to show you 2 more examples, and we're going to go through these pretty quickly. So again, our given statement is that first line with the reason as given, and then you're just going to solve normally. Now, be careful with our fraction problems because we have 2 different types. Remember, we want to get rid of our adding 10 first. So we're going to use our subtraction property, and then we can get m by itself by multiplying. Number 4, we have our given statement. And in this case, we want to get rid of our fraction first. So we're going to multiply both sides by 2, and that just gets rid of that fraction. We're using the multiplication property. And then you're going to go ahead and solve like normal. So using the addition property and the division property. So those are our solving algebraic proofs.